in physical properties. There are numerous physical properties of elements such as melting and boiling points, heats of fusion and vaporization, energy of atomization, etc., which show periodic variations. Atomic radius. Firstly, because the size of an atom is very small. Secondly, since the electron cloud surrounding the atom does not have a sharp boundary, the determination of the atomic size cannot be precise. To estimate the size of an atom of a non-metallic element is to measure the distance between two atoms when they are bound together by a single bond in a covalent molecule. And from this value, the covalent radius is known. For metals, we define the term metallic radius. It is half of the distance between the two nucleus. Atomic radius to refer to both covalent or metallic radius depending on whether the element is a non-metal or a metal. Atomic radii can be measured by X-ray or other spectroscopic methods. The atomic radii of few elements are listed in the following tables. The first table shows the atomic radii across the periods, and the second table shows the atomic radii down a family. The atomic size generally decreases across a period as shown. The graph shows the variation of atomic radius with atomic number across the second period. Within a family or vertical column of the periodic table, the atomic radius increases regularly with atomic number as shown. The graph shows the variation of atomic radius with atomic number for alkali metals and halogens. Ionic radius. The removal of an electron from an atom results in the formation of a cation, whereas gain of an electron leads to an anion. The ionic radii can be estimated by measuring the distances between cations and anions in the ionic crystals. In the following example, metals react with chlorine to form chlorides. The metal atoms lose electrons to become positively charged ions as shown. Here, sodium atom loses one electron to become sodium ion. The chlorine atoms gain electrons to become negatively charged ions. Here, chlorine atom gains one electron to become negatively charged chlorine ion. The chlorides formed are therefore electrovalent. Here, two atoms of sodium reacts with one molecule of chlorine to form two molecules of sodium chloride. And on the right hand side, the diagram shows sodium reacting with chlorine to form sodium chloride, an ionic bond. Question: which of the following species will have the largest and the smallest size? The species are magnesium, magnesium 2 plus, aluminium and aluminium 3 plus. Solution: atomic radii decrease across a period and cations are smaller than their parent atoms. Among isoelectronic species, the one with the larger positive nuclear charge will have a smaller radius. Hence, the largest species is magnesium and the smallest one is aluminium 3 plus. Ionization enthalpy, a quantitative measure of the tendency of an element to lose electron, is given by its ionization enthalpy. It represents the energy required to remove an electron from an isolated gaseous atom in its ground state. The first ionization enthalpy for an element X is the enthalpy change delta H for the reaction depicted in the following equation, while second ionization enthalpy is calculated for the second reaction. The first ionization enthalpies of elements having atomic numbers up to 60 are as shown. The graph on the left side denotes the first ionization enthalpy generally increases as we go across a period, while the graph on the right hand side shows the decrease as we descend in a group. Question: the first ionization enthalpy values of the third period elements sodium, magnesium and silicon are respectively 496, 737 and 786 kJ mole inverse. Predict whether the first ionization enthalpy for aluminium will be more close to 575 or 760 kJ per mole. Also justify your answer. Solution: it will be more close to 575 kJ per mole. The value for aluminium should be lower than that of magnesium because of effective shielding of 3p electrons from the nucleus by 3s electrons. Electron gain enthalpy. When an electron is added to a neutral gaseous atom to convert it into a negative ion, the enthalpy change accompanying the process is defined as electron gain enthalpy. Electron gain enthalpy's main group elements are as shown. Question: which of the following will have the most negative electron gain enthalpy and which will have the least negative? The elements are phosphorus, sulfur, chlorine and fluorine. Also explain your answer. Solution: electron gain enthalpy generally becomes more negative across a period as we move from left to right. Within a group, electron gain enthalpy becomes less negative down a group. However, adding an electron to the 2p orbital leads to greater repulsion than adding an electron to the larger 3p orbital. Hence, the element with most negative electron gain enthalpy is chlorine, and the one with the least negative electron gain enthalpy is phosphorus. Electronegativity, a qualitative measure of the ability of an atom in a chemical compound to attract shared electrons to itself, is called electronegativity. Unlike ionization enthalpy and electron gain enthalpy, it is not a measurable quantity. The first table shows the electronegativity values on Pauling scale across the periods, while the second table shows the electronegativity values down a family.